energy input to do that.
It'd be all right.
It would be all right, exactly. Okay, so here's the concept of indirect evaporative cooling, which is the air and the water never touch. So the humidity on the front end, on the input side, is going to be exactly the same on the output side. So what we're going to use is a polypropylene sheets here that have two separate channels within them, a wet channel and a dry channel. Those two channels never cross of water. You never get any transfer. Only transfer is heat. So we're going to use the water and the air to transfer within themselves in separate channels and be able to produce air conditioning. In fact, we're going to be able to drive the temperature down from ambient, no matter what ambient is. You pick it 85, 95, 185, and we'll drive it down to wet bulb. We're the only company in the world that can get to wet bulb. The highest most other ones, whether it's Deschamps or any of those guys, Munters, is about 80%. And if you'll pull up our website, you can do that, Coolerado.com. We'll get down to wet bulb. So the higher the ambient temperature and the lower the wet bulb, the greater our efficiency. Okay, so let's see if I can stretch here.
Now we can grab you an extension cord.
It'll be close.
Oh.
If it falls, it won't be any different than the TSA guys.
Yeah, TSA beats it up all the time anyhow. So. All right, so what we do is our standard systems, we use a very high-grade EBM German-made fan, backward curved, a variable speed drive and electrically commutated to push air through our unit. As that air moves through our unit, about half of the CFM volume is going to act as the transfer of heat. And it's going to reject that heat to the atmosphere. And we're going to do this refrigeration in 20 different steps. On a psychometric chart, basically, we're just moving to the left and up in small increments 20 different times. And we'll get right to the wet bulb. Using water as the refrigerant. And we can do 6 tons of air conditioning with 800 watts. Okay?
Normally that would be approximately, what, 5 times, 10 times the amount?
About 6 tons is going to be about 6,000 watts, 6 kW. It's about 1,000. All right, so this will act as our ambient heat source. It'll also act as our fan, which pulls the air through the unit. So, what are we doing here on input-output temperatures?
This input? You're at 73 degrees. 73 degrees.
If you did that in the data room, that would be like the hot air return.
This should be your hot air return. And if we can pull off your hot aisle, the hotter you can give us, the better we'll perform. So if you've got a collective plenum off your hot air that we can tap into, it's a perfect source for us. Okay, so what's our input temperature now?
132, 133, going and climbing.
What's output?
69 and a half, and falling.
And what?
And falling.
Okay, now, here's the fun part. You can feel the heat transfer process on the exhaust port here. You can feel a lot of transfer here, a lot of humidity, and then as you draw your hand down, those are the 20 different steps on the refrigeration side. We got the 100-degree delta T yet?
43 and
40 to 65,
We're not
almost.
touching that.
cool.
Yeah, that's way cool.